Hey everyone, Mike Potenza, and we are back to continue our discussion on the different types of analytical models. Right now we're going to look at something called regression. So let's jump right into it. Now, when you hear this word regression, I want you to think back to high school mathematics. That's really all that it was. You remember those good old days in algebra and trigonometry? Well, there was a formula to determine the slope of a line. Y equals mx plus b. That's what we learned in high school. You had points on a line with the x comma y, the coordinate of a point, and m was the slope, the delta y over the delta x, and b is the y-intercept where the line crosses the vertical axis. That's all this is right now. We're about to learn high school math here, okay? So what I want you to be aware of when we're dealing with regression, it is a type of mathematical analysis, and what we're trying to do is do nothing more than create an equation, all right? We're trying to produce an equation, and that equation is going to tell us about the relationships between x and y, what we're going to call an independent and a dependent variable. So this is all based on linear relationships. We're dealing with straight lines right now, and we're dealing with two or more variables. So when you think about regression, I want you to know that regression can be used even in situations where you're unaware of any previous relationship that may have existed between the data. That's okay, all right? The regression analysis can still create an equation for you. So we talked about in an earlier video something called diagnostic analytics. Well, that's what this regression is all about, helping us understand the why things happen. It's all due to certain relationships between data. Okay, so we're going to start with something known as simple regression. But guess what? On the CMA exam, it's no longer tested. They used to test it in the past, but no more. But there's something also called multiple regression, which is tested. She said, well, Mike, why not just teach me the multiple regression if that's what's tested and not the simple regression? Because I can't just jump to multiple regression. We got to start first with simple regression and then step up to multiple regression. Okay, so it's easy. This is all really easy stuff. So let's just briefly start with simple regression. Here's your formula. Y equals beta 0 plus beta 1x plus some little sigma, some little error. So here are your variables. We have y, which is what we're trying to solve for. That is what we call the dependent variable. Now, b0 or beta 0 is your slope, and remember, excuse me, not your slope, your intercept. And remember, this is a vertical intercept. It's where your line crosses the y-axis, the vertical axis. Beta 1 is your slope. I liked it when they used to do M and B because they were different variables. Now they're doing beta 0, beta 1. They sound so close. I get them mixed up sometimes, right? So beta 0 is your intercept. Beta 1 is your slope. And remember what your slope is? It's your delta y over your delta x. We sometimes say the change in y over the change in x or the rise over the run. That is your slope. And then x is your independent variable. And finally, you have this little sigma, this little random error. Okay. So when we talk about simple regression, what I want you to be aware of is there is one slope and one independent variable. That is it, okay? Only one of each. Now, multiple regression, like the name says, is going to be a little bit different than that, okay? Before we go to that, just keep this in mind. You don't really need to study the simple regression because it's not going to be on the exam. You need to study the multiple regression, but it will make more sense now that you've seen the simple regression. So here's your multiple regression. It's the same formula. The only difference is if you look at the simple regression, there's only one term, one slope times